Hello. Nice to see so many people here. Thank you for joining me today. My goal today is to share some ideas with you that I've had about how to improve your application delivery and operations in an organization where you have to deal with a legacy. My name is Remmel, and I'm the founder and CEO at Entigo. But before we dive into the subject, for a few comments from the build staff team. If you want to ask questions and you prefer not to do it in person after the presentation, then there's a technical solution. Here behind your attendee badge, there's a QR code for Slido. Feel free to scan it, and you should be able to submit your questions through it. But if you have nothing against asking the question in person, then after the presentation, feel free. About myself and my background. Despite the fancy title, I still describe myself as an engineer. I have a technical background. I started my career in IT about 20 years ago. I worked as a C programmer and did some enterprise Java development. I got my diploma in systems administration from Estonian IT College. And in 2007, I joined the Estonian government and worked for Citizenship and Migration Board. In 2008, Ministry of Interior in Estonia launched a nice initiative. They decided to consolidate all IT departments from police, border guard, Citizenship and Migration Board, rescue services to one central IT agency, and this one was called SMIT. It was a really nice experience. I was part of the core technical team who helped to make this consolidation happen. I had an opportunity to work in large-scale software projects that involved multiple countries in Europe. Saw a lot of legacy, and this is the period when I got interested in the question how to reduce IT complexity so that our organizations could deliver new features, new software to end users and their customers faster. In 2013, I decided to continue this search and journey as an entrepreneur. So I joined Entigo full-time. And in Entigo, we have worked with companies in Estonia, government agencies all over Europe, and also a few global companies. One of these is Fleet Complete, and I will share a case study from Fleet Complete later in the presentation. But yeah, working in Entigo, it's been always about the question how to deliver software faster and make the operations easier. This presentation is inspired by an AWS event a month ago. I shared the case study about Fleet Complete and how they achieved impressive results with Kubernetes. And after the presentation, well, this is pretty much the feedback I got. Everyone were excited about the results. They were genuinely believing that containers, Kubernetes, and cloud is the way forward, but not for them. For some reason, most of the attendees had an understanding that in order to use containers or Kubernetes or get the benefits from the cloud, they first have to refactor all their legacy, all their monolith, and they have to be all microservices. So the question for me was, is it really like that the cloud native has nothing to offer for the world outside of microservices? Is there nothing organizations can benefit from cloud native technologies like containers if they are working with a legacy code base? First, I have to define what I mean by legacy. As it turns out, in a field of IT, it can mean a lot of things. For some people, it's a mainframe in the basement. For others, it's the code base written in COBOL or something, some other fancy language that's dead by now, or should be. For others, it's the enterprise Java code that is powering the enterprise. So I'll look at a few definitions. First of these was from Gartner. Gartner defines an IT system or a legacy system as an IT system that may be based on outdated technologies but is critical to day-to-day operations. For me, critical to day-to-day operations felt important. If the legacy wasn't important for the daily operations, then we would not be talking about it. We would just discard it. But since we are talking, then it's probably critical. The second really nice article I found was from D-Zone by Eli Lopian. Here are a few definitions from this article. First one, legacy code is code without unit tests. I can remember back when Enterprise Java Beans version 2 was a fresh and shiny thing, and everyone were impressed by it. There weren't that many people who would be talking about testing or automated test coverage. So probably if you see a legacy code somewhere, it doesn't have that much test coverage. Then legacy code is code that is high risk to change. Well, obviously, if you have a complicated system, you have a zero test coverage. It's highly likely you can't manually test it once you change something. So yeah, by definition, it is high risk to change. And finally, the definition from Eli, I think of legacy code as code that developers are afraid to change. For me, this feels important, but for me, it's more of a consequence. If you know you have to take a high risk, it's logical to be a bit afraid. So in this presentation, we talk about legacy applications and legacy code as something that doesn't have a test coverage, that is high risk to change, that is critical to daily operations, and also something that organizations, not just developers, but organizations as a whole, are afraid to change. Now here's our conflict. We know that we need to change the code base, we need to move forward. Our competition is doing that. If we won't move forward, we will lose and eventually will be replaced by the competition. But on the other hand, as we just saw, change is something that we are afraid of. So what's the typical solution for this conflict in an enterprise organization? This may feel a bit outdated description, but the reality, unfortunately, is that we still see this situation in most of the enterprises. First, you have the management at C-level. They know that they recently spent a lot of money on agile coaches. So they're all good. Our enterprise is agile now. We have nothing to worry about. Then probably the development team was also part of this agile coaching implementation project. So developers say, hey, we are doing Scrum, we're all good. But while these guys were trying to learn what the agile development means, operations was busy keeping the lights on and firefighting. So they weren't involved in this project. And they're like, what do you mean a release every week? Do you know how long does it take to manually provision the servers, deploy everything? Oh, no, it won't happen a week. Let's do it a monthly or even less. And it may be that QA is also on the operations side. If you have a lot of manual testing, it takes ages to validate the product, and they don't want to do it every week by the end of each sprint. So the solution is, although the development is doing sprints, maybe releasing code every week, the enterprise will bundle everything up as one large release and will ship it. Everyone should be happy, except the customer who doesn't understand why they have to wait for months to get the feature that was finished in the first sprint. Now, you probably know how this turns out. After the Big Bang release, customers are screaming, services down, management is running around, crisis, fix it. Everyone is looking at the development team, and they're like, we have no clue what broke the system. There are so many changes bundled in one release, we don't know. Oops, that's the answer. It's the code. And finally, when everyone starts to look at the QA, they are the ones who were supposed to test it. QA raises their hand and says, hey, we told you so. You're the ones who ran over the deadline, who eliminated all the testing time. We couldn't test it. So what went wrong? For the initial plan, all the teams were trying to do their best. They were genuinely believing that this plan will work. As we saw, there's still this disconnect between development and operations. Usually these agile consulting projects will help to align business with development so that development will deliver features that are actually expected by the business. But for some reason, many of these projects fail to include QA and operations. And the QA and operations are still left to work the way they have used to for decades. DevOps has been around for years now. DevOps is the thing that was supposed to bridge the gap between development and operations. Have you heard about the State of DevOps reports? Anyone? A few? Nice. State of DevOps report is the longest running research of its kind. They are trying to provide an independent view into the practices and capabilities that drive high performance. The result lets us know the practices that lead to excellence in technology delivery and business outcome. They've been doing this research for 6 years now. There have been more than 31,000 participants. And basically what they do is they look at organizations, what activities are these organizations performing, and how successful are they with their software delivery and operations, and try to map and find the practices that are common in highly successful organizations. They have identified 5 key metrics that predict or describe organization performance. First one is the lead time. This is the time that it takes from git commit to code running in production. The smaller the time, the better. The other one is deployment frequency. How often does the organization ship the code to production? And also failure rate. How often does the release fail? And in case it fails, how long does it take to recover and restore the service? And finally, what's the availability of the service? Based on these metrics, they have divided the organizations to 4 categories, from low to medium, high, and elite performers. And yeah, typically what we see is enterprises fall somewhere here. A bit more what we mean by organizational performance. There are 2 iterations that are important. The first one is the business. The business is trying to bring a new product to market. Today we are talking about products that are software powered, the software based. So also we have the software delivery iteration. In order for the business to come up with a new product, we have to write some code and deliver it. The faster we can deliver the code, the faster the business can come to market and validate if their idea works, and if they are fast enough, they will beat the competition and be successful. Small. One slide from the State of DevOps report. Here you have the things that influence the performance. First, the goal is to have the organizational performance. Here we have the software delivery performance. The major things that impact the software delivery performance are continuous delivery. Here we have deployment automation, continuous integration, automated testing, code maintainability. But also we have change management. And here we can see that heavyweight change management with regular weekly CAB meetings and all the bureaucracy that we see in an enterprise has a negative impact to software delivery performance. And final slide about DevOps transformation is what's the journey for a typical organization if they are going to implement DevOps. Usually they start with having little or no automation. First thing, they bring in some kind of deployment automation tooling and see the first benefits. But this euphoria won't last long, because soon they will realize that due to having low or no automated testing, they still can't release production to the production because QA is still blocking the process. And once they start adding the automated tests, they face the technical debt and see that not all code is testable, and they need to refactor a lot of their legacy code base. But once they overcome this, it's quite easy to push from git commit to production and get the reliable results. So we came up with a hypothesis that implementing a CI/CD for a legacy application or code will help improve organizational performance. And we decided to test this hypothesis. So this is the situation where we were aiming for. First, of course, we need some support from the management. So we're not just an agile company now. We're also doing DevOps. We need to change the definition of done among developers. Done means deployed to production and available to end users. Focus for the ops team has to shift from manually deploying things to providing a platform and providing the automation pipelines for the development to push the code to production. Instead of bundling up a huge release, we should release small increments, for example, weekly sprints. If we do this, hopefully QA will understand that automated tests are actually useful, and investing in test automation in the long run pays off. And hopefully the customer will be impressed on how fast we can deliver the code or features. We tested this hypothesis on a company called Fleet Complete. Fleet Complete is a global software development company established in year 2000 in Canada. In 2017 and 2018, they went through a series of acquisitions. They acquired IT Mobile from Denmark and Bgrowth from Canada, and a company called EcoFleet from T-Mobile was the Netherlands, EcoFleet is Denmark. Fleet Complete has about 30,000 customers worldwide. They have 500 employees, and these customers have roughly 700,000 connected devices sending data to Fleet Complete systems globally. Key partners are AT&T in United States, Telus in Canada, T-Mobile in Europe. Something was in Australia too. After the acquisition, all the companies continued to develop their own product platform. The product that was developed by EcoFleet was rebranded as FC Plus, and this is the product line that we worked with. To simplify things, FC Plus is a GPS-based fleet management tracking and task management solution. You have cars running around, they have GPS sensors on them, and they send data to central system. In the beginning of 2018, there was one massive deployment of FC Plus product. It had around 100,000 connected devices. The platform itself can be divided to 3 subsystems. First, we have the data ingest services. These are the things that are responsible for accepting the GPS snapshot data from vehicles. There are about 25 applications that are processing 1,500 messages a second. These services are responsible for transforming the messages to standard format and persisting them to databases and making the data available for processing in next subsystem. Next one is data processing. There are about 10 applications and roughly 100 different batch processes that turn the snapshot data to a reportable and meaningful data. Like a trip from one city to another, and also GPS coordinates to human readable addresses. And finally, we have the front-end API and front-end logic. This is a large monolith system. It's serving around 300 requests a second. So in 2018, this platform seemed quite solid, but right after the acquisition by Fleet Complete, new problems arose. First, the Fleet Complete had a sales initiative with T-Mobile. They were planning to have a dedicated data center and a new deployment of the FC Plus product for T-Mobile. Also, they were noticing that the IoT ingest service is about to reach its scalability limit. They started seeing incidents after the data volume exceeded 1,500 messages a second. And to make things worse, there was also one customer in Lithuania that wanted to have a private deployment of this product, and one in Estonia. So there were plans to scale from one data center in the beginning of 2018 to 4 data centers by the end of the year. And at the same time, they had to rewrite or refactor large part of the ingest services to keep up with scaling issues. Based on initial analysis, this meant that they have to double the infrastructure and operations team size. So this is the challenge they were facing. When we dig deeper on what was happening with the platform and where the team was spending their time, we noticed that all the deployments were on different platforms. The primary deployment was on a private OpenStack instance. The T-Mobile was about to be deployed to Azure. One of the private deployments was planned to run on VMware and one on AWS. And the challenge here was that all of these deployments were of different sizes. The largest one being 100,000 connected devices, the smaller 100. So you can probably imagine that the deployment architecture for each of these deployments is completely different. So it turned out that the infrastructure and operations team spent most of their time refactoring or writing the deployment code to fit each of these environments. Every change they had to adjust for 4 different environments. What they needed was a way to raise the abstraction level, and this is where the Kubernetes comes in. Kubernetes enabled Fleet Complete to standardize on one deployment platform, and Kubernetes auto-scaling features and auto-scheduling enabled them to move away from manually scheduling workloads to individual servers. So instead of focusing on provisioning, installing, and maintaining Snowflake servers, they could write one code base that can be deployed everywhere. And to move on fast, the team decided that they don't want to spend time and wait until the Kubernetes is available in all the private data centers. They will start the development on AWS Cloud and use AWS managed Kubernetes service for their development and acceptance testing environment. Now the actual project. Do you know Strangler Pattern? Okay. Strangler Pattern is a software development pattern that got its name from nature, from a strangler plant. This plant starts its life up on the tree from a seed. It slowly grows its vines until they reach the ground. Over the time, these vines get stronger. The strangler plant will take the shape of the tree and will kill it. So in the end, we will have a strangle plant that looks similar to our original tree, but the tree is no more. The tree has been completely replaced. We implemented a similar approach for rewriting or not refactoring the ingest services for Fleet Complete. We did fast iterations, at least one release a week. For some features, we did a few releases a day. While we were refactoring the ingest services code, we deployed Kubernetes to all the private data centers. So by the time the code was finished, we had it running on Kubernetes on all the deployments. This is the point where we felt that a better understanding of Kubernetes is required among Fleet Complete software engineers. So we ran 2 pieces of private training for all Fleet Complete engineers. And once we had a mutual understanding of how to use Kubernetes, how it can benefit Fleet Complete, we were able to move the data processing and also the web layer and the APIs to Kubernetes. So what were the results with this project? Team started with 1 deployment in the beginning of 2018, and it's up to 4 deployments in the beginning of the next year or 2019. When we did analysis, we saw that the same infrastructure and operations team, they didn't increase the headcount. The headcount stayed the same. But the team was able to spend 6% more time on engineering activities compared to keeping the lights on and manual tasks. Also, in data ingest services, they had 75 customer impacting incidents in 2018. This is down to 0 customer impacting incidents this year. There still are incidents, but customers haven't seen these, or they haven't impacted the customers. And investment payback for this project was less than 1 year. Now, coming back to the state of DevOps, when we started, we would have placed Fleet Complete somewhere here, medium performer. What impact did it have on the organizational performance? First, we had iterations where the lead time from Git commit to production was about an hour. We did at least 1 deployment a week, sometimes multiple deploys a day. Change failure rate was extremely low. I would say 1 or 2%. So 1 or 2 incidents on 100 deployments. Time to restore was around an hour, thanks to low lead time. And also we saw that availability increased a lot from 75 customer impacted incidents to 0 impact this year. So based on these numbers, I would place Fleet Complete somewhere here as a high performer. So why should you care? Why is it important? Now imagine that you have a complicated software-based product or service offering. Tens of applications all connected to each other, running on tens or hundreds of servers. You know that when you change one thing in the code base, everything may fall apart and fail. You know that your competition is struggling with similar problems. What if you could release new features every day or multiple times a day? How would this impact your time to market and your market share? Fleet Complete now has this capability for FC Plus product line. And they have decided on a corporate level that for their next global product, where they will consolidate all the other products, they will use FC Plus as the basis. So coming back to our hypothesis, I would say that based on the example of Fleet Complete, we saw that implementing a CI/CD for a legacy application or legacy code can improve the organizational performance and move forward faster. You don't need to wait and refactor your code base to microservices first. You can start and get the benefits from day one And when you're looking for a solution for the platform or the automation, then Kubernetes is a really good tool for this. And yes, you can be the first one on the lunch queue. We do offer Kubernetes training. If you're interested, we don't have the dates for Lithuania or Latvia yet, but on our website you can sign up to get the notification when we have the dates. Let me see, are there any questions? Good. So I understand you want to ask the questions in person. Yes, please.
Why you chose AWS, not Google Cloud?
Fleet Complete already had an investment in AWS on the Canadian side, so it was politically easier to go with AWS. And also we've had a really good experience with AWS platform and with Kubernetes. We knew that it works. We had not that much experience on Google Cloud. So I can't say that Google Cloud is bad and AWS better. It's more of a political thing here.
You thought that you invented the integration between deployment. So how do you manage the permissions? Who can deploy it? Does someone have the root access to the Kubernetes?
No, we actually used a project called Flux for the deployment. It's called GitOps. You have your Kubernetes cluster that is following the changes in a Git repository. All the Kubernetes deployment instructions are committed to a Git repository. After you commit, Kubernetes will pick up the changes and apply. So no one should have access to the Kubernetes cluster itself. And for the permissions, you can control these either on the Git level, who has access to commit there, or on the CI tool level. We use Jenkins. We had a workflow for production rollout who can launch this workflow.
Will it work on Google Cloud, on this Google container?
Martin is one of our lead engineers. If you have technical questions, you can ask him later. He knows all the details. You probably will have a chance to find it out soon because we have a plan for deployment on Google Cloud. It hasn't been confirmed yet, but we may find out soon. If there are no more questions, then thank you.